Yes, we want to look at, in our last class, we studied periodic table 1, where we introduce the meaning of elements and some example of elements with their symbols. So in our class today, we want to look at the outlay or outline of the periodic table. Our periodic table are grouped into 8 groups and 4 periods. And how we can put each of the elements in their positions in the periodic table without making any mistake, any technical mistake. So that, as I said in the other time, you can use some, you can use any other means to represent the elements. So the first one is hydrogen, H. The second one is helium. Hydrogen belongs to group 1. Then the next one that we follow is not group 2, does not belong to group 2, 3, 4, 5, 6, 7, it belongs to group 7 or group 8. Helium. I will tell you the way to memorize it without making any mistake. Next one is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So, if you want to use a song, or you can say, or any of the method or strategy that can assist you to memorize and remember it at all time. Like I used to tell some of my students, they can say, libe bisi no me namaga se klaka. So I tell you, libe bisi no. No, we call it together. Libe bisi no me namaga se klaka. Because when you are writing the elements in the periodic table, there mustn't be any mistake. Because if you introduce any mistake, it can affect the way the way you are going to use them to answer some question in future examination. So those are the first 20 elements. Hydrogen, which is the first element, has atomic number of 1. Helium has atomic number of 2. The atomic number is usually seen as a subscript below, while the mass number is written as a superscript. But for the purpose of today's class, we are more interested in the atomic number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Those are the first 20 elements. So let me begin from where we stop now, where we are now. How question can come in the examination based on my experience on the way they ask questions in JAMB, WAEC, NEPO, and NAPTEP, and others. They may ask you, which element of the periodic table belong to group 3 and period 2? Belong to group 3 and period 2. Now, note that hold on. Group 3, period 2. Hold on. It's a past question. It's a past question. In another year, in one of the exams, say, silicon belong to which of the group and period of the periodic table? Do the same. Silicon, this is silicon. Group 4, period what? Period 3. So, what is the other one which are very common? What is the atomic number of neon? Well, anything you write as the source script will represent the atomic number. 10, aluminum 13, 14, and the rest. Are you getting it now? So, then all the elements that you have in group 1 are called alkaline metals. That one is even in NAPTEP past question of 3 years ago. Give any 3 examples of alkaline hard metals. NAPTEP 3 years ago. So by the time you come, I think that periodic table alone can give you 10% of what you need to answer any question in any public exam. Not only in NAPTEP, but and the rest. So example of alkaline metal, even if you don't read your note, you know that just try and produce the periodic table anytime you are in any examination hall. That will be the best thing to do. If you are able to produce the periodic table, then there are some questions you answer immediately without you struggling to do anything. Alkaline metals are potassium, sodium, lithium, and nitrogen. Although hydrogen is not there, because hydrogen is a gas, but although it belongs to group 1, but the metallic part are mainly the lithium, sodium, and potassium. Are you getting it now? So all the elements in group 2 are called alkaline earth metal. Alkaline earth metal. That is another past question. In one of the public exams, calcium is in that group. It's an alkaline earth metal. Magnesium is there, and beryllium is there. Alkaline earth metal. All the elements in group 3 don't have a particular group name. So now go to group 4, which are called metalloids. Group 4 elements are called metalloids. And why are they called metalloids? They are called metalloids because they behave both as a metal and as non-metal. If you look at the allocation in the periodic table, metallic part of the periodic table start from group 1 to group 3 because aluminum is a metal. All these parts are metals. That's why they have positive oxidation number. Are you getting it now? Yes. So from group 5 to 7 are non-metal. So this group is standing between the metal, so they are called metalloids. They behave both. They can ask you in any exam, why is carbon a metalloid? Carbon has the ability. That's why sometimes they behave like a metal in compound like carbon 2 oxide. Normally, metal should be the first element when you are writing the formula for any compound. But look at carbon now, standing there. Carbon 4 oxide. Exactly. So can behave like both metal and non-metal. Silicon is another element in that group. Then we now have group 7 elements. Group 6 don't have any special name. Group 5 don't have any special name. Then group 7 are called, okay, let's go to group 8. Group 8 are called inert metal, inert gases. Inert gases. Ask you to give some examples of inert gases in many exams. Helium is there, neon is there, and argon is there. And why are they called group 0 anyway? They are called group 0 element because they cannot take part in any chemical reaction. They simply have 0 valency. They can't take part in any chemical reaction. Have you ever heard about a compound bearing helium chloride? I've not heard about that before. Or neon oxide. You can never see that. So they cannot take part in chemical reaction. So that is why they call group 0 elements. Group 7 elements are called halogens. Yes, that one is also a past question. It's in several public exams like JAM and the rest. Which of the following is an example of halogens in the options? Especially we are talking about the first page. We have halogens in other periodic tables. We have periodic table of 400 elements. We have periodic table of 700 elements and the rest. But for the purpose of this class, we are limiting ourselves to specific elements. So you should be able to see fluorine and chlorine there. Others that are not here are like bromine, iodine, and the rest. They are also halogens. But they are not the first, they don't belong to the first 20 elements of the periodic table. They belong to the next group after maybe from 21 to 30. Are you getting it now? So then having known that, another thing you can derive from the periodic table is to establish